Good morning everyone. Today in this video I am going to explain how to use the kit in your microcontroller lab and how to interface with the different modules, how to execute the program. So this is microcontroller lab, and so what are the software required for this? That is keil software. You need to download C51 keil software, and operating system we are using is Windows, and programming tool you are using is Flash Magic. So here are the steps how to create a project and compile your microvision project. So start with double click on the microvision icon on the desktop, and if it is already some projects are open, just go to project and close the project and start a new project. Go to project and click on new project, and here the next step is you need to select the device. So you see in your microcontroller kit which device you are using. In our lab we are using P89C51RD2XX or P89V51RD2XX. So whichever is there, you just select that and click on OK. Now we have to write the program. For that, go to File and New, create a new file, and here for this you can use assembly language, or to write the code you can use assembly language, or you can use C programming. If you are writing a program in assembly language, you need to save the file name with the extension .asm. If you are writing your program in C code, you have to save the file with the .c extension, and you need to add your file to the source group. For that, right click on the project and source group window. You just click on add existing file to the group and select your file or browse your file and click on OK. And next thing is you have to give a crystal frequency, and you have to select the hex file. For that, options for the target, go to project, options for target. In that, right click and you select some 33 will be there. You just delete that and give the crystal frequency 11.0592 megahertz, and check out the create the hex file. You just click click there, and then we'll see how to execute the program. So go to project and translate project and build the project. If there is any error, it will show the error, and if any error is there, target will not be created. So debug the errors and rebuild the project. Your target will be created, your X file will be created, and then go to debug mode and run the project and observe the output. Simulation output you can see like this. So here you can see the board. This is the board we are using in our lab, microcontroller board. As I already told you, we are using two ICs or devices, that is C51 and V51, and this is the main microcontroller, and it is you can see this is LED interfacing, this is DAC interfacing, and one more is ADC with temperature and LCD interfacing. These are the experiments we are going to do in our lab. For this, we need to you can see here, this is RS32 cable connector. So we need one connector, that is USB to RS232 cable. That one we need, and also you need to give the power to this board, right? For that we need a 9 volts adapter, and to interface with this main module to other modules like LED module or DAC interfacing, you need to use the FRC cable. So just I'll show you. So this is the connector, USB to RS32. This one you are going to connect to your CPU, and this one to your kit, RS32 pin to kit. Okay, this is 9 volt adapter. to give the power to microcontroller board. You are using this, and these are the FRC cables. So interface with microcontroller board to LED board like this. All modules to connect with all the modules, you are using this cable, FRC cable. Okay. Then I already explained you how to execute the program. If you want to see the simulation output, already I explained you. So here we'll see how to execute the program, how to upload the program to your microcontroller board, and how to execute it. So build the project. Till that, same steps. After that, see here you can see the switches. One switch is there and two LEDs. One is red LED execution mode and green LED is programming mode. Okay, first before dumping, you want to upload your program. Right now you have to upload your program. You are written the code, everything is done. You build the project, that is also over. For that, first you keep the switch in programming mode. Just press on this switch and green LED will glow. So that is programming mode. Okay. Then you launch the Flash Magic. Here also you need to select the device. You check in your board, you observe in your board which IC you are using. P89C51RD2XS is the MS, you select that device, or else P89V51RD2XS, that you can select. And you are connecting USB to RS32 to board. So for that you need to select the COM port. For that, just right click on the computer, click on the manager, and devices and ports will be there. Just you check there which port you are using, COM3, COM5, like that. Select the port. Then select the baud rate, 9600, that is the baud rate. And in the second block, Flash Magic, you have to erase blocks is there. Just select that. And you need to browse your X file. So just browse your X file. If you are creating a project LED, means the X file will be created by project name only. So led.hex will be there. You just select that X file and upload the program. Start. You click on the start. Once it is verifying, erasing the blocks, then programming, then verifying, then finish, uploading will come. After that, you switch again, press on this switch and go to executive mode, EXE mode, and then press reset button and then observe the output. After pressing reset button, you can observe the output. So here are some modules I am showing you. So this is ADC with temperature module is there, and also LED interfacing is there. So here is a small red pot is there. So if you vary that pot, you can observe the temperature variation, some 00 to FF. You can observe the temperature variation, that we are going to do here. And LED interfacing, you can type something MC lab. Display, you can display your name or something, MC lab or Shobha, anything. You can do that. And this is the LED interfacing. Here some LEDs are there. So this is one, you have to connect output port from microcontroller to, you have to connect out. Switches are there. So these switches and interfacing both switches and LEDs, you can write the code and you can observe the output. LEDs on and off. Okay. Then stepper motor is there. So in your syllabus, stepper motor is there. So you need to connect stepper motor to here in white pins socket is there. Here you can connect. You can observe the output in red LEDs. You can observe the output. This is stepper motor, how it is running step by step. You can rotate the stepper motor in clockwise or anti-clockwise, or rotate some rotation and stop it there. Like that you can write the code and you can observe the outputs here. And this is the last module, that is DAC with buzzer. So you can connect this J23 is there. Now here you can connect the props from the CRO, and you can observe the output on CRO. In this you can um, see the square wave, triangular wave, ramp wave, like that. Okay. This is about the different modules what you are using in your microcontroller lab. Just an introduction. Hope you understood. Thank you.